Example 4. Example 4 says, find the solution of the differential equation 3 dr by d theta plus sine theta is equal to 0, given that r is 5 when theta is pi by 2. So let's start by writing, we have 3 dr by d theta plus sine theta is equal to 0. I would start out by doing this. 3 dr by d theta is equal to minus sine theta. So positive sine theta goes over and become negative. Then I'm going to have 3 dr is equal to minus sine theta d theta. Then I'm going to integrate both sides. Now, if I integrate 3 with respect to r, I'm going to get 3r is equal to, if I integrate minus sine, I'm going to get cos. So this is cos theta plus c, which is the constant of integration. All right, we're given some boundary conditions. We're told that r is equal to 5 when x is equal to, when theta is equal to pi by 2. All right, so let's put in the boundary conditions to determine the value of c. So we're going to have 3 times r, which is 5, is equal to cosine theta, which is pi by 2, plus c. Now, the cosine pi by 2 is 90, and the cosine of 90 is 0. So this is 0. So what we have is that c would be equal to 15. So what we have for a particular solution is that 3r is equal to the cosine of theta plus 15. If I divide the entire equation by 3, I'm going to end up with r is equal to 1/3 the cosine of theta plus 5. All right. So let's continue. All right. So let's talk about solution of variable separate differential equation. This says an equation of the form dy by dx is equal to f of x times g of y, where f of x and g of y are functions of x and functions of y respectively, can be rearranged to the integral of 1 over g of y with respect to y is equal to the integral of f of x dx. Now, an integration of this form where we can separate the functions of x and y is called a variable separable equation. All right. So let's have a look at an example of a variable separable differential equation question. So this is example 5. Now, example 5 says, or example 5 is asking us to solve the differential equation dy by dx is equal to 4x plus 1 divided by y plus 2. So let's write that. dy by dx is equal to 4x plus 1 divided by y plus 2. All right, we're sort of going to do a sort of like a little cross multiplying. So we're going to have y plus 2 dy is equal to 4x plus 1 dx. Then I'm going to integrate both sides. All right, so here, there are two ways I could do this integral. The easiest way to do it is to say, if I integrate y, all right, it really is it the easiest way. So let's integrate this way. We're going to have y plus 2. We're going to raise the power by 1. And so the power becomes 2. And I divide by the new power, which is 2. Over here, this is equal to 4x squared divided by 2. And if I integrate 1 with respect to x, I'm going to get x plus c, which is the constant of integration. So what I'm going to end up with is y plus 2 squared is equal to, or over 2 multiplied by 2 is equal to, all right, no need to do this. So let's just correct quickly. All right, so it means therefore that y plus 2 squared over 2 is equal to, this is what, 2x squared plus x plus c. Then I'm going to multiply both sides of the equation by 2. I'm going to end up with y plus 2 all squared is equal to 4x squared plus 2x plus 2 times c. C is a constant. If I multiply it by 2, I'm going to get another constant. So I'm just going to replace the constant 2 times c with another constant d. Now, the opposite of square is square root. So I'm going to have y plus 2 is equal to the square root of 4x squared plus 2x plus d. And positive 2 goes over and becomes negative. And so I have y is equal to the square root of 4x squared plus 2x plus d minus 2. All right, and so this is the solution of our first variable separable differential equation. Let's have a look at least one more example. Example 6, it says solve the differential equation. So let's write it straight away. Y dy by dx is equal to tan x plus 2 over cos squared x. Now this is the same as saying y dy is equal to tan x plus 2 multiplied by 1 over cos squared x. Now 1 over cos squared x is the same as saying sec squared x. So this is sec squared x. All right, and I have dx here. Next, I'm going to integrate both sides. So to the left, I'm going to have y squared over 2. If I integrate y with respect to y, I'm going to get y squared over 2. I'm going to increase the power by 1 and divide by the new power. Over to the right, I'm going to have the integral of, I'm going to remove the bracket by applying distributive law, tan x sec squared x plus 2 sec squared x, and I'm integrating with respect to x dx. So now I have y squared over 2. Now if I integrate tan x sec squared x, I'm going to get tan squared x over 2 plus, if I integrate sec squared x, I'm going to get tan x. So this is 2 tan x plus c, the constant of integration. Next, I'm going to multiply the entire equation by 2. So I'm going to end up with y squared is equal to tan squared x plus 4 tan x. If I multiply c by 4, I'm going to get 4c. C is a constant, so 4c is also another constant. So let's simply change from 4c to b. Now, the opposite of square is square root, but I'm wondering if, should I apply the boundary condition now? Should I apply the boundary condition now? Maybe I should, to see if I can find b. The boundary condition is y is 1 when x is pi by 4. So y is equal to 1 when x is equal to pi by 4. Let's apply that to see if we can find b. So this is going to be 1 square is equal to tan square pi by 4 plus 4 tan pi by 4 plus b. All right, now the tangent of pi by 4 is 40 degrees, 45 degrees, and the tangent of 45 degrees is 1. So this is 1 is equal to 1 plus 4 times 1 plus b. Now we have what? 1. So therefore this is what? 1 minus 5 is equal to b. So therefore b is equal to minus 4. So our equation is y is equal to the square root. The opposite of square is square root of tan squared x plus 4 tan x minus b, plus b, which is minus 4. All right. So this now would basically be the solution of the differential equation, and the solution is this is a particular solution because we know the value of the constant is minus 4. So this is y is equal to the square root of tan squared plus 4 tan squared x plus 4 tan x minus 4.